Hi students. In this lecture, I am going to discuss rotational mechanics. First, let us see the list of concepts. Rigid body, kinematics of rigid body, torque of a force, equilibrium of a rigid body, moment of inertia, relation between torque and angular acceleration, law of conservation of angular momentum, rolling motion, instantaneous axis of rotation, impulse and collisions, and finally toppling. So these are the concepts I am going to discuss in this chapter. Okay, let us see first one. It is rigid body. Okay, so rigid body means its shape does not change, or you can say distance between any 2 points in the body remains the same. So if you are taking a body, if you apply force on that body, still its shape is not changing. The meaning of rigid body. So shape not changing means distance between any 2 points remains the same. So in this chapter, we are discussing only rigid bodies. That means their shapes and we can say size also not changing. Okay, right. Let us now focus pure rotation. So whenever a body is rotating, there must be one axis of rotation. Okay. And what is that? Means how to know that? It is the locus of all points having zero velocity. Let us see in detail. For example, we are taking a sphere. Suppose it is now solid sphere. So it is now rotating about one axis. Let us take axis is now diameter. So we have taken a solid sphere. It is now rotating about diameter. Now we can see any point on this diameter that will be at rest. Any point on the diameter, it will be at rest. Now we are saying this point as the locus of all points having zero velocity is called axis of rotation. So how to identify means for which points velocity is zero, axis is passing through those points. So it is locus of all points having zero velocity. And if you focus remaining all points, they follow circular path. For example, I am taking here, suppose it is a disk. A disk is rotating about its own axis. That means passing through center and normal to plane of the disk. Okay. Now we can see all points means except the points on this axis of rotation. Remaining all points are following now circular path. Okay. And you can see if you take any 2 points, for example, let us take now 2 points. Suppose this is point A and this is a point. So here we are saying that all points are following circular path and their center will be on the axis of rotation. So A follows now circular path like this. And B follows now circular path like this. So for all these circles, center will be on the axis of rotation. Okay. And we can observe one more point. When A completes one revolution, B also completes one revolution. Or we can say Each and every point completes one revolution in same time. That means angular velocity is the same for all points. Also, alpha value, which is known as angular acceleration, it is same for all points. And if you take angular displacement, suppose now this line is now at one instant is like this. This is now A and this is B. And if you take now this angle, that means line joining the center and A, line joining center and B, it is now covering same angle in same time interval. That means all points are covering same angular displacement, all having same omega value, same alpha value. That's why we are calling as it is angular velocity of the rigid body. And alpha, it is also for the rigid body because for all points omega same, alpha same, theta same. So instead of saying for one particle, it is now for entire rigid body, right? So here key points, whenever a body is in pure rotation, a pure rotation means axis of rotation is stationary. One condition is when you are saying pure rotation, axis of rotation is stationary. Second thing, all points are following now circular path. And for all the circles, center will be on the axis of rotation. And you can see between A and B, separation is always the same because it is a rigid body. That means along the line joining them, there is no relative velocity. I am repeating. Since it is a rigid body, along the line joining them, there is no relative velocity. Okay. Next, for example, distance of A from axis, take it as R1. Distance of B from axis, take it as R. Okay. Or take it as RA and this is RB. Okay. And now we are discussing that omega same for all particles. It is omega of the body. Then if you observe velocity of any point, or I can say here velocity of point A. So it is now omega into RA. This is omega into RB, right? This is now velocity of direction along the tangent. This is velocity of B, direction again along the tangent. So if you consider relative velocity, it will be normal to the line joining them. I am drawing here separately. This is a velocity VA, which is equal to RA into omega. For B, velocity, it is VB, which is equal to RB into omega. If you find relative velocity will be normal to the line joining them. And see that value how much? It is RB minus RA into omega. Okay. And from this see what we can say here. Omega equal to V relative. So here no need to mention that this is a normal to line joining them because it is obvious. Separation between any two points does not change. Therefore, V relative means it is normal to the line joining them, dividing with separation between them RB minus RA. This is giving us angular velocity of the body. Okay. So I am saying here one is if you imagine one line on the body, okay, by what angle that line rotates, that is now angular displacement. So I'm making diagram once again here. We just imagine one line on the body. After some time, this line makes some angle theta with initial orientation. Then theta is now angular displacement. So now we define angular velocity. It is now d theta by dt. If you remember, the same thing we have discussed in circular motion. Here also same, because all points are following circular path. Direction will be along the axis of rotation, right? Okay. There is one more definition for omega, that is in terms of this one. So this is now written as velocity of ith particle with respect to jth particle is equal to omega bar cross r bar of the ith particle with respect to jth particle. So I have written same thing in vector form. Okay. So this is giving us both magnitude and direction. So if you want only modulus value for omega, simply focus relative velocity. That is normal to line joining them. Divide that with a separation between them. Then we get modulus of omega. This is now definition of omega, or we can define in this way also. Right? Let us now see key points regarding this. So first of all, axis of rotation. The locus of all points having zero velocity. Next, all points except the points on the axis of rotation follow circular path. Relative velocity between any two points is perpendicular to the line joining them because it is a rigid body. Therefore, separation between any two points does not change. That means along the line joining them, there is no relative velocity. Okay. Next, all points are having the same angular velocity and same angular acceleration. Okay. The same theta, same omega, and same alpha. Right. Let us now focus on problems. How to calculate angular speed. Okay. See the question carefully. A rod of length 5 meter whose one end is resting against a vertical wall and its other end is having a constant velocity 10 meter per second. You can see in the diagram, rod of length given, okay? Asking its angular velocity when the rod makes an angle 30-degree with the horizontal, right? Let us see how to start it. Right, first make the given diagram. Let's see diagram given. Rod length is 5 meter. So this is now rod which makes angle theta at one instant. Because since rod is now sliding, angle keep on changes. And this velocity, this is a point B. Its velocity given as 10 meter per second. And given this as a constant. And this is a point T. So we have to find angular velocity how much? When theta equal to 30. Right? And length is given 5 meter. So this is now given data. Now see what we can do. So just now we have discussed omega equal to d theta by dt, right? So here we can write theta as a function of this velocity. See how to take it. So we can write OB equal to, it is now x-axis and this is y-axis. So I can write OB. OB is now, it is equal, I'm taking it as this distance equal to x. That means, see, what is the x coordinate of point B? It is equal to, it is equal to L cos theta, that is 5 cos theta, right? And we are given its velocity. That means dx by dt, that value is now given as 10 meter per second, right? So, and we want to calculate omega, which is d theta by dt. So if you want to get d theta by dt, we have to differentiate this, right? So differentiate this. So dx by dt, that is equal to 5 into derivative of cos minus sine theta into d theta by dt, right? So now see what we can do. In the place of dx by dt, it is now 10. So here x is increasing, right? Therefore, dx by dt will be positive. 5 sine theta. When theta equal 30, sine 30 will be 1 by 2. And I am taking here minus, okay, outside. I am writing here minus d theta by dt. Okay. If you see carefully, in this theta value keep on decreasing. Okay. That means d theta by dt will be negative. Negative of negative will be positive. Okay. So 5 here 2 times 2 2 so 4. So minus d theta by dt is a 4. Let me cross check. 5 and 10 2 times 2 plus 4. Okay. So 4 radian per second. As I told you, d theta by dt is negative. So negative of negative, it is a positive. That means how we are starting problem is, here we know how to relate theta value with a given velocity. Then after that, just differentiating that, we get the answer. Okay. So it is depending on the problem. Is it like taking d theta by dt or finding relative velocity and dividing with a separation between them? Okay. Let us see next problem. Right. See the question. A rod of length L slides down along the inclined wall as shown in figure. At the instant shown in figure, the speed of end A is v. Then find speed of end B and also angular velocity of the rod. Okay, let us see. So first make a diagram, that given diagram. So it is given an inclined plane. So now taking the rod of length L, rod of length L. Right. This is now, this is a point B and this is a point A. Let me take, right, point A. This is point A. And given velocity of point A at this instant is V. It is V. So we have to find velocity of end B. So VB value how much? Next we have to find angular velocity of the rod. Okay. And see, given this angle is beta and this angle is alpha at that instant, because these two angles keep on changes, okay, with the time. Now see how to start the problem. So it is now a rigid body. It is a rigid body. Then its length does not change. That means along the length, relative velocity must be equal to zero. Okay. So I'm taking components here along the rod length and normal to rod length. So first take along the rod length at point A, along the rod length. This is beta, then this also beta only. Then this is now V cos beta. Okay. Next, velocity of B. It will be along the inclined plane. This is VB. Okay. It's a component along the rod length. That will be VB cos alpha. Okay. So now condition is that since it is a rigid body, its length does not change. Therefore, V cos beta should be equal to VB cos alpha. From that, we are going to get VB value. That is V cos beta upon cos alpha. Okay. So we got the value of VB. Now see how to get omega value. In this, we are knowing velocities for point A and point B. So when we are knowing velocities for 2 points, then we can take relative velocity normal to line joining them and dividing the separation between them. Okay. You can see here for this V velocity component normal to rod length. It is V sine beta, and this VB is like this. One component is now like this, right? That is VB sine alpha. Okay. And you can say these two are opposite. Okay. So V relative velocity is equal to, it is V sine beta, V sine beta plus, y plus means if this is a positive, this will be negative. Okay. Then minus of minus becomes plus. So V sine beta plus V naught sine alpha upon this is relative velocity, right? Divided with separation between them. That gives omega value. Now in this we have to substitute. So this is VB, right? VB. So now substitute the value of VB in this one. Then you are going to get omega value. So in the previous problem, we have taken d theta by dt, because in that we are able to get theta as a function of the known values. In this, we know velocities for 2 points. Then finding relative velocity normal to line joining them, then divide with separation between them. Okay, right. Let us see next problem. Right. Two particles, two particles A and B of a rigid body are at a distance 2 meter apart. Condition given rigid body. Okay. So in a rigid body, we are focusing 2 points or two particles. Separation between them is given. Particle A has a velocity of 10 meter per second, and particle B has a velocity V as shown. Right. Find angular velocity of the rigid body and also find the value of V. Okay. Let us see now how to solve it. Right. This is a point A. Its velocity given, its velocity given 10 meter per second, and this makes angle 60. Next, coming to B, it makes angle 30. Its velocity is V, which we have to calculate. And separation between them given 2 meter, separation 2 meter, and condition given, these are the two particles of a rigid body. So between any 2 points, separation does not change. That means along the line joining them, relative velocity must be zero. That means that means 10 cos 60 should be equal to V cos 30, right? So cos 60, it is 1 by 2 V cos 30 root 3 by 2, right? 2 gets cancelled. So V equal to 10 upon root, so meter per second, right? So we got velocity of point B. Next, focus now how to calculate angular velocity of the rigid body. So we have velocities for 2 points. Then what we can do? Finding relative velocity, then divide with separation between them, right? Separation is now L, which is equal to 2. V relative, then see how much? 10 sin 60. 10 sin 60. I will show again diagram here. This is 10 sin 60, and this is V value at 10 by root 3 sin 30. Both are in the same direction. So V relative 10 sin 60 minus 10 by root 3 sin 30 upon separation between them, that is 2. Okay. Now see calculation. Let's see how much we get. 10 sin 60. First of all, I am doing it 2 cancels here. It is a 5 and this also 5. So take 5 outside. So sin 60 root 3 by 2 minus 1 by root 3. It is now, I have taken 5 outside. Sin 60 root 3 by 2. 1 by root 3 sin 30 1 by 2. Again take 2 outside. 5 by 2. Remaining is root 3 into root 3, that is 3. 3 minus 1 upon root 3. Check calculation once. 2 taken outside. Root 3 into root 3, that is 3. 3 minus 1 upon root 3. 3 minus 1, 2. 2 gets cancelled. This is now 5 upon root 3, right? Radian per second. That is angular velocity of the rigid body. Like this, we can find omega value either by using relative velocity by separation between them or d theta by dt. Okay.